2, 3, funky.
This question could be easily answered by looking at the formula, and if you were to look at the Q1 and Q2, you could see that that is equivalent to the charges, and that's the answer for that. This was more of a common sense question, and everybody should know that your electrons are always going to be negatively charged. Here's another question that's also dependent on the formula. It can only be equal to all of the top, so the product of the two charges, because your K is always going to be constant, so that doesn't matter. Don't forget it's inversely to the bottom, and also because it is squared, it's inversely proportional to the squared. And yep. Okay, at this point, if you ever see anything conservation of anything in physics, your answer should automatically just be that it cannot be created or destroyed. And if you really think about it, your charges cannot be created or destroyed. They can only be transferred between one another. It can only take away the electrons and make it negatively charged or positively charged. And whatever you start with is what you're going to end up with charge-wise. So if you start with 0 for neutral and you end up with negative 500 on one and then 500 on the other object, if you add those together, it's going to give you 0. So yeah, it cannot be created or destroyed, only transferred and stuff. This question is something that I went over in my last video, and basically it's always going to be stronger. And I feel like the reasoning behind that is because your force of electrostatic can be attractive or repulsive, but your gravity can only be attractive. In order for anything to be neutral, it has to be balanced. So balanced in this case would be the same number of protons and electrons. Again, with the stuff that we should already know, like charges repel each other, opposite charges attract each other. That's just that. Okay, so with the direct charges and everything, the force and charges are directly proportional to one another. So if only one of them was doubled, then that would basically be like 2 times 1 if you use the rules of 1, and that would be 2. So your electrical force would only be doubled instead of quadrupled because only one of them was doubled. Okay, so don't let the wording like throw you off or anything. Basically, it's just describing the equation of the force or whatever. And so basically, if your distance is halved and your force is inversely proportional to the squared, first of all, you would have to inverse it, and that would be 2. And since it's squared, that is 2 squared, which is 4, so quadruple. Again, with a similar question, but now you're going to double your distance. So first of all, you would square that, which is 2 squared, so 4. Inversely proportional would be 1/4. So your electrical force would be cut to 1/4. Also, I hope you guys notice how I'm not saying that your electrical force is going to be equal to 1/4, because it's only going to be affected by that much, not equal to it. Now there's similar questions asking about relationship and stuff. If you were to double the charges, what would happen to the force? It would quadruple. Again, rules of 1. If you put in a 2 and a 2, 2 times 4, that would affect the force by 4 times, so quadruple. I feel like there isn't much to explain with plugging in equations and trying to solve this stuff. Just don't forget with the negatives and everything, there's always to be a positive charge and a negative charge. So whichever one is a negative, sometimes they don't tell you the word problem. Make sure you put in a negative or you're going to mess up the equation. Don't forget, divide by distance squared, and that's that. Okay, again, we're following the equations and plugging in stuff right. The E represents the times 10, and then you just follow with the whatever the exponent is. Again, if your answer turns out with a negative in front of it, it's going to be attractive because opposites. And if it's a positive, it's going to be repulsive because they don't like each other. So they separate and stuff. Okay, so for the first equation, I used the one that has charges, which is the positive and negative one on the top. And then for the other one, which is gravitational force, I used the masses and actually just switched it around. This is the charges one, Coulombs Law. The first one was gravitational force. And yeah, that's that. And electrical force is going to be greater.